Okay, so this evening's presentation is entitled Track Maintenance Innovations with the McCulloch Group, and I'll pass you over to William whenever you're ready.
Okay, no problem. Good evening, everyone. As you'll see from the right-hand side, this is a very last-minute appointment for myself, so please bear with me because I've not seen this presentation before. So we'll take it nice and steady, and we'll move through it. So my name's Roy McCulloch. I'm Business Development Manager for McCulloch Group, and we have Billy McCulloch, who is the owner and inventor for McCulloch Group. So what we generally try and say to people whenever we speak to anyone in the UK or internationally, and what we try and make the difference in setting us apart, is that we are railway people first and foremost. My dad's worked in the railway for 30 years. Yeah. I've worked in the railway for 15 years. So the big difference from us to anyone else internationally in that regards is that we actually operate the equipment. We don't produce equipment and then sell it internationally. We design, build the equipment, operate it in the UK, and then it goes internationally. So we can not only just provide equipment, we can provide people with that equipment. So whenever we go to a new territory, we can supply specialist operators to help with the methodology on the ground, not just supply equipment. And that's worked out really well for us. So as you'll see here, this was 30 years ago by twins, Billy and Danny, so my uncle and my father. It started off as W&D McCulloch, ran out of Doljarrick, and then we moved to Ballantrae, which was head office. We now have our head office located in Kilmarnock over 2 locations, where we have our corporate offices and our manufacturing facilities. So this is a brief history of where McCulloch Group have got to. So we were founded in 1992. If you want to jump in at any point about the history of that. 1982, we were founded by cutting trees at the side of the railway line, and my dad had the opportunity to, probably you better explain this a little bit.
It was actually an article in the Glasgow Herald that BR had put in one of these Brigden Stratton chippers. They cut 1.5 inches of wood at the time, and I thought we were sitting with 8-inch chippers cutting trees for the council, and that's how there's. When I seen the article, I came up and there was the product acceptance days was a guy called Harry Shepherd, Harry Watson, and Ken Whitemore at Shettleston. That was the people that actually guided me to how to go onto the railway, and that was my first ever shift. A guy, section man was called Frank Connor, believe it or not, out at Moss End. Which is Pierre Frank's no longer with us, but he was he talked the right to the wrong, put it that way. But he was a good guy to work for. But that was how the first one ever came about.
And then we move on to 2005, where the TRT was invented, and that came about from having witnessed people try to move rail. We first tried to use the Unimog.
The TRT actually came out a bit called Long Nuke at Paisley, believe it or not. I was there with the brand new coal must come into the country. Caledonian had them either in isolation, put in isolation, and first engineering in the days with David Traynor says, well, it says, with that wee machine you've got, so we had an arm on the Unimog, and we put this to a square, so we fed the rail into it, and we drove it out to bring the scrap out. Because they were days we lifted, our first thing was scrap, believe it or not, that was our very first in the railway. And then we built this square on the Unimog with an arm. So we could do, after this road to that road, you could do the 6 foot. So next week he says, that's it. So put this rail in. I think there were 300-foot strings in the days. That was the biggest rail. So I started with youth, use all with 60 foot, then we went to 300 foot. Now we have a standard size of 709s, which we have today. Whereas, so I was putting that in eight minutes with this machine. So it was revolutionised. That's it. No men barring how to do it. And then all of a sudden, so David Traynor says, look, cancel the machine next week, Billy. You can do the cess side. Disaster, we bent it because it was too far out. So, and I went home that night and as most distraught, shall we say, but how did this happen? How this? And so I watched the television and that. Well, I don't really watch television that much. And this kid about so high was lifting this ball, and the centre of gravity of this ball was rocking this thing back and forward, and I'm sitting watching it. And I couldn't work out what they're trying to do. And I woke up about probably 2-3 in the morning. I thought, that's what it is. Now, you don't know what a 56 is. So I don't know why I've got 56 on my back door. to have this 56er there, and I held the 56er out 1, 2, I had it 4 seconds, and it was too heavy. I walked out. My wife came to the door at this point. What are you doing? It's raining. It's the middle of the night. What, somebody breaking the house? I'm holding this weight. That's 1, 2, 3, 4. I let it go because I was bored. And that was the day that my machine was born, because the centre of gravity. Somebody very clever that worked out for me about if diggers need to lift this, that, what would you jump on your back for a digger? Diggers are only worked for the fact that you brought a digger to feet 8.5. It sits in rocks, whereas my machine lift you and it's stable. It'll never tip. Can it tip? Because centre of gravity is where it should be. And that was like Isaac Newton stuff was like that day. That's how I worked it. It was just a case of that's how that machine was born that day.
That's really been run through the rest of the products for the panel lift on the flask. Everything's centrally mounted, everything's lifted below it, so that it's all, the weight distribution is all there. We're never lifting anything over and above. And we'll come later how that's given us a little bit of advantage working ALO in different countries. But just moving on, where we really went internationally was during a family holiday to New York. So we were very fortunate the fact that London Underground and New York and different transit agencies have it's like a round table event where they share best practices. And London Underground gave a presentation to New York, and our machine was in it. So my dad and I are actually going on holiday, and we contacted the people in New York several times, no response. And it was the last day before we left where they agreed to finally have a meeting, and we were fortunate enough to go. And they loved the idea, they loved the concept, paid for us to go over and do a trial. The trial was a huge success, and we're very fortunate. Now we've got 7 machines working for New York City Transit. We've got a few different products there now. We've just delivered 3 ramp systems to help them deliver products and material and equipment down their tunnels.
We went there to New York. There was something like 32 deaths. Right, the compensation claim was an 8-figure sum. It was printed in the Wall Street Journal 1 year after McCulloch were there. It was 0. That's a fact of life. That's all printed.
There was a lot of manual methods still being used with what we would call rail dogs. So still rail dogs. So there's a lot of hand and foot injuries with ankles injuries. So the TRT obviously removed a lot of that manual handling. So it allowed them to split their production teams down into 3 or 4 different teams, spread the TRTs out, and then increase their production. So I think they increased the production about 300% by having the TRTs there. So just quickly moving on, there's a few slides to go through. The next adaptation of TRT, we've made it fully remote control, which we'll come to a wee bit later. We acquired a company in Hurlford or Kilmarnock, which was S&C Engineering, and that now is our main manufacturing facility. So they build the TRTs and build our R&D products. And in the last couple of years, we've went from McCulloch Rail to McCulloch Group, where we've now got a CEO in place. We've got a full executive leadership team. We've now got functions within the business, and we're now set up where we can really expand quickly if we need to.
The engineering was one of the key points in my life, because I hate fear, right? I want to walk into the place, get that job there, and have that within the client within a matter of hours. I don't want to go somewhere and it's like 3 days to draw something. I just want to tap something to that's your priority now. And I don't mean get it done, but right, this is what I want you to do. How that functions. So my biggest thrill in this world is animation. I love animation. No Tom and Jerry stuff. Love Tom and Jerry too, but animation is probably one of the biggest things. You can actually control what you're doing, the speed you're controlling it, how it does it. And as I said, if you see it there, it's actually working. There's a digger does this, a panel machine does this, a flash machine, and you can put it all together. So you put timers in there and the client, and it doesn't matter what language we're in. That's all the other language. There should be French, German, and railway.
So I touched on slightly earlier what makes it different in the fact that we operate the equipment, but we're again very fortunate. So working in the UK and especially Scotland has given us a unique set of challenges that we can take elsewhere. So in Scotland, UK's Victorian Railway, there's no real straight lines. It's all round bridges, tunnels, viaducts, cuttings. So we've managed to adapt to that in the UK and create like single line working methods. We work in remote locations, and that's really helped us set us apart internationally. So we're working with big companies in America where their main thing is trains. They're freight trains. They're millions and millions of pounds for these trains. If they have to stop that train, it costs far too much money. So if they have two lines running next to each other in a lot of areas, for example, Long Island share a track with Amtrak. So you've got two different power sources. You've got third rail and overhead. For Long Island to go and carry out their work, they need Amtrak to turn that power off, whereas our machines allow them to work without having to contact Amtrak or turn that power off. So it gives them a little bit of advantage where they don't, against traditional methods that they use, where if you've got anything with a boom, you have to contact because you can fill that opposite line. It's the same in SEPTA. SEPTA have a different gauge. They have different between their city sections and their I think it's the transit sections they call it, but there's different power. So they have all different. They have overheads. They have third rail. They have fourth rail. They have different gauges on two of their different sections. So the TRTs don't have to adapt to any of that. There's no cost to go from working underneath power to working to third rail. There's no cost to going from working at standard gauge to slightly different gauge. So it's given us a lot of advantage working in the UK first to then use the methodologies and practices elsewhere. So this is just some of the original machines in their newest forms that we have. So we've got the TRT on the right-hand side, which is the newest version, which is what we call the TRT Mark V. So up here you'll see this is a halo light system. It's still getting approved in the UK because the blue light interferes with the RCIs for excavators. The TRT doesn't have that issue because it doesn't have an RCI. So this basically emits a blue halo light system so that in the dark there's a blue light goes right around the machine, so for exclusion zone, so that everyone can see exactly where that machine is moving and where you shouldn't really be. And there's also cameras on it so that the operator has full visibility around the machine. This machine's fully remote controlled, so it allows the operator to operate and assess away from any machine movements. And that was critical for the ALO working. As we just talked about, it means the operator can be in the cess the furthest away from the train and the far side and still operate. And there's no boom to swing and potentially fill the opposite line. We've got an electric hoist at the back, so it takes away the manual handling for the rail to be put into the rail handling head. And then we've got additional lighting just focusing on where the tracks are so the operator's better visibility. And then we've got the panel lifter on the left-hand side. So again, the panel lifter is fully remote control. The panel lifter, one of its main features and the best design features, in my opinion, is the panel lifter will come in. These legs here will come fully in, and it will come fully compact, allowing it to be transported by road. And that's been a huge asset here in the UK because you don't need a rail path. You don't need a train path, sorry. You don't need to interrupt other work sites. If you're working in Manchester one weekend and your next job's in London, Glasgow, you can go by road. You don't have to transport it by rail. So as we talked about the TRT Mark V, so I don't know if you're fully aware of the rail PPS system, which is every time a machine works in UK rail infrastructure, it has to be signed off by Network Rail or the client, sorry, to say if that machine has been reliable, if it's an issue that night, if the tracks maybe come off or the engine's failed or anything, we have to sign it off and Network Rail have to sign it off. So I think we're slightly less than this now. I think we're 99.3, but we're 99.3 proven reliability because the machines have been designed to be simple. They're designed that if there is an issue at 3 o'clock in the morning, that 2 or 3 people on that site can fix it. You don't have one person in the whole of the UK with the experience or technical ability to fix that machine. There should be 2 or 3 people in that team that will be able to fix that machine. There's a recovery engine that will attach to the back of it and a complete engine failure that will allow the machine to go off-site. There's spare tracks available. The tracks are easily put back on. Everything's been designed to make sure that machine will work and it's easily recoverable and easy to fix. Same with the panel lifter. The tracks are a little bit heavier, but again, if there's any issue with these tracks, these little pads just unbolt and bolt back on. So again, it reduces cost for us as a service side in the UK, but also for customers internationally. If you have an issue with the tracks, you don't have to replace them, it's only replacing the pad. If you have an issue with anything in here, they're easily available. The engines are standard. You don't have to come back to us in a specialist arrangement. You can go down to your local Kubota supplier and get the parts. And the same with hydraulics. Everything's been made to make sure it's as easy and simple for the end user as possible. But this is just a quick video of the panel lifters working. So recently, when the panel listers were first designed, they were really designed around 60-foot panels, which is really what we did for a long time. It was actually New Zealand who started moving larger and larger panels, and we've started now doing this in the UK. I think the biggest we've moved now is 70 or 80 metre panels, and that's a case of just getting onto like a bridge or a viaduct or anything that you just need quick access to. The panel listers will remove that. I think we removed the bridge in Newcastle for Nexus within 5 minutes, a 70 metre panel, and it allowed access straight away, and we put it back in within 5 minutes. So I'll just play this video, hopefully. You can see the operator on the left-hand side. You can see we're obviously going through a tight area with the bridge here, and we're working under overhead live wires. So there's no chance of anything coming off the machines and filling that wire.
Single operator controlled.
No, they're all independently operated, and it's only the only reason being, and we get asked that a lot, and it's if one of the machines are going around an obstacle, it means the first machine can start going around that obstacle while the other people are in the straight line.
Good.
I do have a video that I could probably show you.
You can actually stand this. See if you stood this back corner of this machine here, you kind of see what that first machine's doing. It can fall into the manhole. That was
why I asked the question.
This is the ideal conditions because it's daylight, but in night time you've no visibility.
Right.
So everyone has to be by their machine.
And look at that, panels as straight as you want to be.
And that's one thing that we're trying to promote as much as we possibly can. Like here in the UK, we handle rail quite well. When a lot of people drag rail out, they don't handle it as nicely as it could be. And there's you get a lot of rail fractures, especially in different countries like maybe Canada, where there's a lot of severe weather when you're going from maybe 40 degrees in the summer to 40 degrees below in the winter. So the more that we can handle that the rail well, it means there's less chance of the fractures going through. And that was the same in Australia. I think one of the companies had put in rail using excavators for riding in the top, and I think there's like 9,000 faults within it. Whereas handling the rail a little bit better like this, and with the TRT where you're holding it below, you're not creating any stress.
It's a good sustainability angle. Reuse.
Absolutely.
Purpose and handle it well.
Again,
In my defence, see if it looks right, it is right. That's what my theory is. Because if that looks level straight, it's right. So you need this different and that the stresses and that is there's no. That's how we decided. There's 4 machines. You could probably do it with 3, but have a big different lift the machines right up. There'd be a big sag in it. You don't want that. You want it so it looks that way.
No, as soon as you get a break, then that's delays. It's the way that we were explained in the class ones in America where they're millions of pounds. It's fine for the first train. If you're going from 50 mile an hour to 30 mile an hour, the first train's impacted, but it's the last train that's cancelled because you've the delays right through the network.
And all that there arrives in one lorry. You've no got a lorry per digger. That just folds up into the same natural shape, drives on the back of the lorry, you get 4 on it.
And that's a big thing as well from companies also try to cut their carbon emissions. The fact that we can arrive in one loader, one lorry can be easily transported. Same for the TRTs. It's a big advantage for us. So the TCT, you probably were explaining how the TCT came about.
So this is obviously the TTC. So one day this is a 20-man cable pool, right? So I was watching. So take me down the London, I think it was. So whatever happens is, so there's a study. The tallest guy goes first to the smallest guy, and you take a meter between the guys to the cable. It's like a caveman put it there, right? And that's how they work their scale now. So when I say to him, so how does that work out? So I watched this guy doing all right. That's fine, right? And all of a sudden, these 20 guys. So when I went to see the job, there was 25 guys. So I thought you told me it was 20 guys. No, he says you go to 25 guys because if 20 turn up and 1 doesn't turn up, you've only got 19 guys. You can't pull the scale wrong. I said, this is bizarre. Right? I said, do you see my problem? I said, it's parking, right? Because 24 kids. So we get involved in some PA people up in Blindon.
Irvin.
Irvin people, they came to us and I was with Net Worry Irvin, they promoted this machine. And so we said, right, what do you actually want? We want a machine to go from there to there with as little as men as possible. So they can do different things with their men. They're slipping and they're no dragging cable. So we cut this machine about 3 times, if I remember right.
We did.
3 different sized cable drums. So this machine went out one night and I think it did 5.5, no, I don't think, I know it did 5.5 kilometers with 2 people in the one night. Right, so actually, well, I'll tell you what, we need to sit with network rail, and anybody that does cabling, because also I'll use my can of beer. Can you see me? The can of beer's right. So what happens is, so this is a scenario, right? So that's a 500 meter cable, that's 500 meters, and that could be 200 meters. So that's you 700 meters. So I sit there and going, right, we'll take this wee piece here away, right? Right? That's us get 700 meters. The bit of taking it away is the weakest point in the job. It's called a join. So I said, right, we'll build 1 ton, 2 ton, I think we've got a 5 ton machine now. So we can run cables from here to here with no joint. That's what it might be. Doesn't matter what size, this is always the weakest part. So that's how that machine was born.
And yeah, so
It made perfect sense to me, because
and we're very lucky. Like Urban P were fantastic. They
Oh.
came, they worked with us, they let us trial the machine on their site to make sure we're getting the production that they wanted to. No, and we're really
so we're
fortunate.
going to these are going away to God knows where they're going to wait to tune that, but that's so Urban, they were like, right, I tell you what, let it blast. So the process is, right, how do we get the bigger machine? And that is how they work, it's sitting and doing and understanding somebody's problem. That's all this is. It's no, we don't need to reinvent the wheel. I just need to work out what the problem is and take this piece away.
The next machine we have is the MMPB, and this is our first rail-mounted machine that we've invented, or you've invented. Do you want to explain a bit more about it?
Right, so this is I spent a right lot of money on this machine, right? I knew fine that I wanted so I went to involve Glasgow University and some people that was right clever, a lot clever than me. I wanted to build something that there was one isolation that so if you put a road rail digger up, right, a trailer, you go to load up, that clock is still ticking, right? So load this up, right, and then you can go. So I thought, how do I work out its mere productivity from a daytime men, because daytime men are daytime men, that's where they are. Nighttime men only get 4 hours on that line. So if they've got to load it up and unload it, I came away with 2 hours of that job. Right? So you go, well, I've only got 2 hours on the railway line, it's not really worth the hassle. So I thought, if I could build a machine that could slide across, lift itself up, slide it across at 4 foot a minute with 40 ton on it. Somebody, I went to Network Rail and nobody laughed. No so much laughter. It's not possible. I went, everything's possible. Don't worry about it. Men in the moon. I'm convinced it's possible. So first attempt, I bent it, right? Bent it, built it. Didn't matter, right? Didn't work. So went to my friend at Glasgow University, and he worked to it. And he worked to it very quickly where I went wrong. And so we worked to it. So this machine was made. We built it again, we built it with different types of steel, the different strengths of steel. So this machine lifts itself up, slides across, hydrostatic drive. If I have a heart attack on the machine, it stops. Every safety feature in that machine is there, right? And there's a case there. So that means that can go, so when we were in Canada, keep remembering, you ever watch a program called Road Rail Alaska?
Yeah.
Right, so watch it. So they've got a digger goes onto this trailer and it drives up into the anchorage right up into the mountains for 3 hours, right? So that's 3 hours of driving. That means that is not working. I don't care what anybody says. When you're driving the rail line, you're not working. It's a digger. So it gets this job, right? Then it starts putting this rock down. It gets a phone call from God knows who. The train coming. He's got to drive that down. I know it's television, right? So that's 6 hours of his day is lost. And I'm sitting, so my wife doesn't watch television as a band because I switched the phone stuff at the television. I said, no, up there, 5.5 hours, let me work. This, I'll put some 4 pads down. I'll come off the rail line, lay the train goodbye, get back on, and I'll continue working. And that's why that was born, because I was worked out that. So the new ones is no. This is this power pack here. So the new ones are starting to build the power packs actually on the blow. So I've got a full 40 or 60 or 8 feet deck. The crane runs up it, which is beautiful. The crane runs up it. So as I say, Tunnel London Underground. The crane lifts there, runs up the crane, runs up it, grabs this panel, lifts the panel back on there, takes it back to the station, puts there, brings a new panel, puts it back up. That was one of the features there, because everything I've got in that machine there is a cartridge. I can be 40 ton of water, 40 ton of stone, 40 ton of men, for any at all I can put on that machine. You can think you're in that room, I'll shove it, because I made 2 rails on the end of it like a train, made 2 rails, so I pull these pins out, take that machine off, then put a new one on. So you'd only buy, so if you buy a tamper, it's a tamper. See tomorrow, start tamper. See you next day, start tamper. That's the difference. That machine is a that's the real machine, because you can do anything you want in that machine. Anything in your mind, you'll do with that machine.
Yeah, it's been designed to be as multi-purpose as possible. And just to touch on something you said there, so it's actually heading away to Australia, because one of the big issues that Australia and America have, they work in between trains. We see the freight trains, we work with CSX, you only maybe get 4 hours, and it's a case of you're ready to go when you get a phone call. It's not planned at a certain time because you have to wait in the train. The train's the most important thing. The train has to run. So as soon as that train goes by, you get on and you have to get straight back off when you get the phone call the next train's coming. So that machine allows that to happen. You don't have to come 3-4 miles back to the access. You can come off, let the train pass, and go straight back on.
And if you wanted that, a specific piece of equipment, you wanted in Glasgow, and you wanted in London tomorrow, that thing lifts us up and run. Your lorry reverses on a block, and it'll be running tomorrow by road.
It goes by road. So again, you don't need any
That's
train
why I
back.
wanted it.
So this is just another couple of videos of recent jobs that we've done with the panel lifters. I'll just move this on so that it's
That must have been doing so. I think that's been set somewhere.
So you can see, obviously, the difficult location of this. We're right in the middle of cutting. There's no room for anything, and I think that was a 50-meter panel we moved that day.
A lot of people were asking us, like, what's the weight of these machines? The weight is what you want it to be. If you tell us tomorrow, we've got 6 tonners, we'll get 7.3s, we'll get 9 tonners, we're building 25 tonners, it doesn't matter. It's what the client, if you want whatever it wants, it's the modern day technology, just onto that computer and away you go. What was the things, TRM? No working there.
No,
No work
the
in there.
TRM there, no.
That's what I'm saying. There's never going to be 100% of everything. We're railway people. We're open to everything. You even suppose double line, single line, you go to get the best piece for you. But if you imagine that in my line of work, right, these are railway people doing me. In my line of work, there's 3 types of railway people. You've got people that can put in double track, railway people all day, just do it. I'm that guy. Then you get single line railway people, half this room would go away. Then you get tunnel railway people, single line, that's a different animal. When we went to New Zealand, that was, the tunnels we had to bring the machines in, they were scraping the paint to lift this. I don't know if you want to touch that,
I do. I can.
doesn't matter, but this was as tight as we were. We were in from Auckland to Vangaree. It was X amount of money, I can't remember what it was, but we did this stuff. And when they said was it was a bore a tunnel. So they were going to drop this bit here and make it this kind of shape so that the high cube containers could go through from, there was a powdered milk to go to China.
Yep.
Right, that's fair enough, right? So we see it, fantastic, we can do this job. Measured the panel machine, oh, we've cracked this, never did, right? Didn't do that way, didn't work out. They got these wee nibbling machines, right? And they nibbled a wee bit of rock here and there, and they dropped the panel down, and so the rail was like this kind of shape. Your panel machine can do what there? It could not work, and I'm sitting going, right to it. Get us a test track up on Vangaree. So an 82-foot panel, we're sitting there going, right, looking at this panel, looking this way, looking at the panel, looking at this. And then it occurred to us, see if we move 6 sleepers this way and 2 that way, we created a gap for the panel machine to sit in. So the panel machine was short, its narrowest bit, and we lifted up like a pair of trousers. We walked in, set it down, then spread the sleepers. That was it. We won every turn lift that was within. Sorry, we were 13 tonners, we won 12 because that one was flat track, and that was how I won it. It was just to sit there looking and going, how just sit? Because there is a way of doing stuff, you see, look at it.
So this is something that we're actually developing further, but we actually did a switch S&C job with the panel lifters. You can see the spreader beam here. You were actually on this job.
It was 34 metres. That was supposed to have been 2 pieces, but I decided we went to a job, I looked, I thought, maybe we could do this in 1 piece. So we put 2 machines at the one, the wide end, obviously the wheel end, and 1 in the nose, and I thought we could do this. And we lifted it, and up lifted it, I thought, see when you lift, see when you lift this back to my old spin. I lifted it and it looked absolutely straight as a die. I thought, That's right. Put it back down. Quick, put it back down. And went down that night. And I knew fine we could, as long as I was running it that way and no turning, because you've 3 machines you can't turn. Because a middle machine does not work. And that's how you've got to run in this and run back out. And that's so I get the, I can't remember who the contract was, and they moved a wee pile of stone from it so we could run straight in there. And that's how we did in that job.
So
So I
what?
didn't.
It was story.
So I was that.
Sorry, yes. We are currently developing a 25-ton system that will lift turnouts. We've had a lot of expressions of interest and a lot of conversations around that in Australia and America at the moment about lifting big turnout sections in. So these are a couple of case studies. So this is one of our companies we work with quite a lot in Australia, Effective Rail. So Effective Rail have, I think they've got 12 TRTs and 2 sets of panel lifters now. So they are operating like a service style business in Australia, where they service people like Sydney Trains and ARTC, and basically they're trying to expand all across Australia with the McCulloch equipment. So one of the main things that Effective Rail managed to do, so there was a lot of industrial action in Sydney Trains, where the main thing is they were never allowed to work under live wires. So what Effective Rail did, they utilised the TRTs to allow them to start working under live and get past the industrial action, and it allowed them to really showcase the equipment and really gain the trust of Sydney Trains that they could offer an alternative solution rather than front end loaders or diggers, and it would be a safe solution. They could operate at any point, and the main thing for them was to get into midweek working. They never really did midweek working before because of the power. So the TRTs allowed them to do this, and it's really taken off for Effective and for us, and we're delighted with that partnership.
As I said, that they're getting the men midweek, they're running, the men's running, and as I said, that's where they can roster the men for weekends off, they can go and do the there's a 4 every time in Australia, the weekend work with weekends. That's what you don't want. You don't need to work in the railway to sign up to weekend. We've all got lives here. This is what to get it.
So this is just a couple of photos of Effective Rail showcasing the TRTs, and a fantastic job that they've done promoting the machines in Australia and really operating them well. They've done a fantastic job trying to get into different markets, and they've been doing a lot of different things with the machines that we've potentially not even done along the lines of that tunnel job that we've seen last week.
Melbourne Tunnel, the videos I've seen in Melbourne Tunnel is unbelievable.
This is a job that they've done. You'll see the remote control TRTs working, and this is them putting in a switch.
It's a 10%, I know.
Well, taking it off, yeah, sorry. So you'll see just jumping over the foam ramps, taking it off site, under the wires, fully remote control.
And that's the operator here. So he's never going to get up.
It's staying nice and level, it's not distorted, and that's
It's staying nice and level.
that's a big one.
And
The switch. Oh,
Yeah.
I love steam switches.
Did you say it was a foam ramp?
it's foam. We used to use metal,
Used
but
to They weren't too to get wet, they're not used.
wetter. See, as soon as the slightest bit of frost, the track would spin. The foam is actually it's expensive, but it's great stuff. Like we would never go back to it. It's made company in Glasgow actually,
It's probably got 3 years in the Bahamas and what it is.
but it's great stuff and it lasts forever.
You would imagine it would compress and that would be it,
Aye. No.
but no.
No, it's really great. So this is one of the newest developments we have. So we actually have a fully working TRTE. It's actually trialled 2 or 3 sites around Scotland. So the TRTE was basically designed in the concept of the TRT. It has the same duty cycle as the TRT. We managed to deliver this with a few partners, including Unipart there, Williams Formula 1 team, and Hyperbat. So this was designed around obviously the future where everyone's trying to lose carbon emissions, especially for working tunnels and for work in sort of urban areas, try and reduce the emissions and also the noise. So it's been great. We're really happy with it. We're designing our own version of it now to go into production. This was the prototype, but the industry's still trying to catch up with the demand for the battery vehicles at the moment. So we're in a good place. We've got the the design all there, we've got the production ready. It's just a case of now trying to get the machines delivered out to the correct people, which is probably going to be hopefully Network Rail to start with, and then into sort of the transit systems.
Biggest drawback. I used the machine the first time in the Primrose Tunnel, and its biggest. To my father, it's quite funny, but its
That's
biggest
that
thing.
here, actually, sorry. That's that here.
Oh, sorry. The same, what's the same responses, same, probably a wee bit quicker, but that's saying it's so. But as I say, his biggest thing is you hear it swim.
So there's no emissions in that machine at all. So in the tunnel environment there, you don't need to have the extractor fans. Everyone's in there safe. It's definitely a little quicker.
Oh, it's definitely.
It's definitely nippy.
But that's the thing. It was quite used for me to use it. And in fact, I came back for it. I don't know where I was in the world, and I came back, and I knew this job was on, and I just went straight up to it. And those people allocated it. And this guys grabbed the remote control.
Which
I said, no, this is my baby.
this job actually took place probably within 4 miles of where the W.D. McCulloch started. Your dad, Papa's property in Bojaric.
Yeah.
I shot it before, by the way.
And this is it, and actually where I stay in Maywell. You see, it just does the exact same job as the TRT. Same duty cycle. It's designed to last 8 hours without needing charged.
And a full operating 8 hours.
A full operating 8 hours, and with these sort of shifts, as soon as you take that rail out, you can turn it off.
Right.
Because time the repad and then you turn it back on, so you're actually got more than the full shift. You should really be able to do 2 shifts.
So is it these lines that sit tick, 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 tick,
Because you're never constantly working for 8 hours, so it means you can turn that off.
I hadn't realised that you could work so close into the platform.
Yeah.
It's one of the great advantages, the fact that the tracks can actually go in, but you're not fouling the platform here.
I'll show them some
Well,
mitigations.
No, because the weight is spread out, so the tracks are actually 7 foot long, so the weight distribution across the tracks, so it means the actual weight per cubic inch of the TRT is very low, so it doesn't really disturb. You can run along the top of ballast shoulders, or you can run the far side or the near side. What we normally tend to do if we're in sort of any areas that we don't want to disturb or there's a steep drop off, we would just move the machine over slightly and run on the sleeper ends, and then you know that you're not disturbing any ballast shoulders, or if there is a.
They had platforms erected, shoulders.
There's a plough goes on the front of the reinstate it.
So yeah, I mean you can just run on the concrete or the sleeper ends here, so you're not disturbing anything.
Yeah.
So the Infinity machine is actually the next evolution of the TCT. So the Infinity machine here actually has, or the next version of it will have forks at the back to allow us to lift palletized materials, and that a lot of that was driven from Australia and our partnership with Effective Rail. So because obviously Australia is such a dry heat and it's so warm all the time, before they weld or cut, they have to have water down the track. So this is a way to allow us to take cubes of water down the track without, again, fouling any overheads. It means you don't have to turn overheads off. We can take the water down the track, allow the welding or any hot works to take place, and the water's right there. I'm assuming, obviously, it's the first time I've seen this, so I think what we're talking about next year is what we're looking at internationally. So at the moment, we have a good presence in North America. We have a lot of machines out there, and we have a lot of machines in Australia. But the one place we don't have any machines at the moment is Europe. We've done 2 or 3 test runs, one in the Netherlands and one in France, and it went really well. And we're still in discussions with trying to make that a more permanent solution. But the focus for us in the next year, probably through the next 3 years, is to really expand more in North America, Australia, and really target Europe. There's a lot of, obviously, rail in Europe. There's a lot of different infrastructures. There's a lot of main operators similar to Network Rail, such as SNCF, such as Deutsche Bahn, such as Renfe. And it's really to try to get in there, either through the government agencies themselves or via the contractors, So these are our main 3 areas for the next sort of 3 years. We do have ongoing discussions in Brazil. We've got some ongoing discussions in Thailand and the Philippines and a few different countries in Africa. But the next 3 years is really to try and focus on these 3 areas and set up entities and really expand.
Really interested.
And with it.
It's really should love all that.
We actually spoke with IEF. We actually met 2 gentlemen from Israel that had a huge amount of program, and we're still in discussions with them. But yeah, we've never been. But that's just really everywhere.
Light rail and tunnels.
Absolutely.
Blast doors and the like. That's the kind of thing I'm looking at.
And that's the thing. Like, no matter where you go, everyone has the same issues. It's the same issues with access. It's time. It's working in really difficult locations, or working in between trains. But yeah, we're happy working anywhere as long as there's a market for it and it can help.
In Jerusalem and in Tel Aviv that are coming to completion. They'll go back into maintenance, and then
That's it.
in 2 or 3 years' time, they'll need to be handling stuff.
And we're starting to replace the.
And that's a market for you guys, I think.
They're actually doing a lot of work now in Egypt. There's a huge high-speed network now in Egypt. So it's the same with the Middle East. The Middle East as well, yeah.
Jordan to United Arab Emirates and everyone in between.
I'm not sure I cash in that probably a long day.
Not at all. I just don't want to pay you.
So that's the presentation finished. If anyone has any questions, or potentially wait till my dad's back and he can answer.
Brilliant, thanks, William. I don't have any questions so far on the chat, so
Do you want me to come out this so that it's back to the? I'll just leave
no,
it.
you're fine. You'll probably find people want to jump back to certain
Very
bits
well.
anyway. So
I've got a couple of observations and a question. Your business model.
Yes.
I absolutely liked it because it's so in-house and you've got such ownership of it. You design and build machines, and the design's done by railway people. The machines are for railway people, and they're operated by railway people in the railway industry. And that is an absolute great idea because it gives you, in the rail industry, the ability to spot the next big challenge. And that's what I think you've done in your evolution of different types of machines. Your machines have been invented and developed, all driven by a need somewhere along the line. And whether it's Billy saying, "Wait a minute, I could do that with this if I adapted that." And all that's assisted by flashes of brilliance along the way and waking up at 3 o'clock in the morning thinking, I can fix that. And I love that kind of light bulb moment, they call it these days. But the flash of inspiration is how the railways managed to get out of the mines all the years ago. Because somebody said, do you know what? We could do away with these horses if we got something to haul these hutches out of the mines. And that's how the railway was started, invented, progressed. I liked your idea, Billy, that your engineering animations overcome language barriers, in that engineers, wherever you are, when you look at an engineering animation of what your machines are doing, you don't need to tell them. They can see it on the screen. That's a brilliant thing. And the best bit for me was in the problem solving, when you said, pulling on a pair of trousers. No, we're going to pull on a track panel and lift it, like lifting up your skirts with a track panel around about a machine. That was absolutely brilliant for that. My question, if I can come to a question, was about your research and development costs, I'll call them. So when you set out with your partners like Unipart, Williams Formula One, universities and the like, do you ever have a finite budget where you say, right, I'm going to allow that amount of money to develop it and then stop? Or is it a case of once you've started, you put money at it as long as there's an end result? I'm conscious that you built a machine, it didn't work, and you went to clever people that come up with different types of steel and stuff, and eventually you did get something that worked.
Yeah.
So do you ever set out in an R&D budget.
In the old days, no. In new days, yes.
That's because you're not got a structure.
That's the thing you have to
Because
operate on the
I
structure now.
was driven probably more. I was probably driven in the days more with passion. There's new I'm answerable to people now, because I've got to try and convince people that this is what is. Whereas I like to see things happening there and then. Whereas I do find that, as I say, back to our clock here, in the railway times, Saturday night, Sunday night, that's fair enough. But midweek is where we need to be starting working. Whereas if I could get that machine to go this way at 4 foot a minute and drive hydrostatic, come off, I've gained every advantage, because if you've got to load a trailer up, I've taken time off that.
And that's exactly the principle. And I remember way back in the early days of first engineering, we got involved in re-railing in Devon. Devon has really tight curves. 190 meters is the most you can pull in one go. So WSP, sorry, first engineering invented the simultaneous multiple pull for stressing. And the guys in Swindon and Railtrack at them couldn't believe how much we were pulling every night. How can you possibly? You've got to pull this little bit and stop. No, you look at the big project. What do I want to do? How can I do it? And that's exactly, and I applaud it, exactly the approach you take to inventing your next machine. And I can't wait with interest to see what your next big thing is, because it's absolutely fantastic what you do.
You know, we're very fortunate. With R&D, we always try and take a long-term view, and we're very fortunate in the fact that we always say if somebody has an issue, it's not isolated to that one person. So with Kiwi deal with an issue with their tunnels, but every country will have an issue with their tunnels. So we have to invent something. We don't look at all that upfront cost and put it onto that one person. We can look at it and go, if it works here, great, and then we can maybe try and get it working maybe 3 or 4 different places to try and spread that cost to the customer as well.
But the important thing is you identify the problem.
Absolutely.
And you get the end result over in another corner, and you join the dots.
Yeah.
And that's the bit that I'll call it knacky people are able to do.
And that's the thing. It's
We talk to people all the world, like Sweden, they'll all sit and go, oh, but we've got tight tunnels. Then we show them, I've got nothing like New Zealand, because it's not a gauge. It's meter,
yeah.
right? And we're sitting there scraping the paint, and they're sitting there going, we can't have the panel. So we put a roof, they put this thing on the roof, on the tunnel, and they take it down, and I'm sitting going, no, what's this? I'm sitting there, what, it's like, no, I said, we would not do that. We take it. It's not possible. I said, just make that gap, lift it. And they went, really? I said, that's what we did. And you get the same amount of sleevers, and we just need to do that.
Yes, spread them back out.
That's why,
spread them back out.
because
Yeah.
you've got to feed them in. Or you don't want to do that.
But you do all this R&D with one eye on safety. You're always aware that you've got railwaymen out there working your machines, and they're on that site. You've protected the zone. You've got machines that are, if they fail, there was a mechanism to get them off the track.
That was a big, I can say this, that I would never build a machine, even that big machine we built, I've got a second engine there. It comes with it, because I would never have, I don't want my name in lights to say, oh, I held this up, I need a crane to take me off of that. That machine will get it. It's not the fastest, I'll be honest with you, but it gets off the line.
Because, as a wise man once said, you're only as good as your last foul up.
That's it, yeah.
Looking at the development, Billy, what is really
No, thank you very much. Yeah, absolutely.
do you get much external, whether it's commercial or government support towards research and development?
Yeah, I mean, we are very fortunate. We work with Scottish Enterprise, and Mindy and Alan look after us tremendously. They help if we need to go to a new market. They'll help us. They'll help us when we get to the trade shows.
But even this morning, with a call with a gentleman in Perth in Australia, and Mindy's William says the she helps because there's a bit of problem getting a machine, how to navigate the carnies and all this stuff, and that
Basically, import a machine.
machine to Australia, you've got to wash it with, you've got to take all this. This Scots guy was there talking away. Lord Mold, it's for Kilmarnock, and he's in Perth in Australia talking away. He says, but I don't know. He says, your machines are actually fantastic. There's hundreds of lot for this machine. He's not from the railway, but he just knows. I said, right, you need to tell us What's the best way to get there? It's not a flat rack, it's something else's.
Well, it's a Matthew flat rack. It's an out of gate load, so it's caused a lot of issues, but Scottish Enterprise have helped tremendously.
It's good to hear that it's, if you like, genuine support, because you keep reading about, we're doing this, we're doing that, and you go, well, are they really? But no, genuine support.
No, Alan and Lindy have done tremendous amount for us, and we're eternally thankful for that.
That both way, what's the process? The client comes to you and says, can you do this? We've got an idea, can you, or do you go to the client with ideas? Or
No.
just 50-50?
The old likes of the TTC, that was up in PV, came to us, they're from, and I loved it. We've got flippers, so we flew to show off now, we flew out to New York to look at how they tipped the rail. They had all these men with their hands trying to bring this rail, right? So we were watching, my God, if somebody didn't like somebody, just let the rail go and their hands. Look,
Fingers of these
aye,
days.
honestly, their fingers, it's just horrendous. So honestly, see, we made these slippers, so depending on the client, that's where we would love to get to. The client came with the thing all the time and say, look, can you solve this problem? It's not so much a problem. How do we get that there, this man away for that machine, right? So we even make this. So what happens in New York? So they bring the TRT. So they weren't using the TRTs the way they should have been using them. The way they're designed to use, they decided by the time they built. So I said, well, show me what you're doing here, and I'll tell you you're doing. There's nothing to do with TRT. The TRT was totally irrelevant. So we went, it was the delivery of the TRT was the problem. So they've got 14 men on a Friday night building this ramp system to get TRTs off. I'm sitting there going, right, so that was it. So it's like, so the train carries this, so they bring this plate about inch out, quarter inch, and they put out, they put these great big bolts into it, then they bolt this thing to this, then they put these ramps out, then they put the safety up, and I'm sitting there watching this, we were all watching this, I'm going, almost a full shift building this ramp, and if you pull this plate and it falls down the train, that's it, the game's over, right? I'm sitting there going, right, that's fair enough. So for us to sell more TRTs, to get them, so not so much sell, for them to be the most beneficial out of our TRTs, we need to get the delivery system better for them so they can use it midweek. Right? So that made perfect sense to me. So I went back to US Transit and said, look, we'll go back, we'll sort this. But underestimated what I was up against was, right, I'll tell you what, we'll build a set of flip toe ramps off the back it, we'll build them on there. Right? That's never, we don't own the train. Right? So you can't build onto the train. So, right, that's fair enough. Right? Next question, right? We'll make it there so that, right? The motorman stands 3 feet to the end of that train. So as a guy stands 3 feet here, and exactly 3 feet there, brings the train in. There's a set of boards here. So the ramp's going to be here. He's got to see. I say, it's all right. This is where it gets interesting. He gets after the train and goes and says, so it leaves me this blank cartridge here. Funny weld onto the train, and we don't want the train. So that's it. But I want the system to get this off. So they said it, right, if we did this way, did that way, right, so we're back here in Scotland, go a design team, and we said, right, if we do this, how do we do it, right? So I don't know if you're aware of, some of you are in the room, some of you are in the room, you know what a box of matches is, right? Right, so it's the same principle as a box of matches. So a box of matches does this, does this. So I worked out that if I set a cartridge on this, like a 2 cartridge, so the first cartridge pushes the 3 foot to here. Then the next cartridge, then you tie that bit down with a TRT. So the TRT pushes the cartridge to here, exactly there. Then you take that drawbar off. Then you put the cartridge on the next tier there, and the TRT pushes the aluminium, they call it aluminum by the way, out to there. So right now I can install, I can deploy that ramp in 2 minutes and 30 seconds with 1 man.
Instead of a full Friday night with 15 men.
And they've all got their fingers.
Precisely.
So we're just looking at, but that was where, if they'd have said, which was fantastic, I loved the project, I really did, it's one of our best things I've ever worked on, but that was where they wrote, so nobody's one client, 2 or 3 clients knew that actually subbing to New York City Transit, they have bought the same system, because they have the same problem.
But your brilliance, Billy, is identifying the problem and applying the principle of a box of matches as a cartridge system to push a drawer out, which then pushes another one out. And it's that bit that identifies the inventors from the people that operate. Right, so you're an operator inventor, or an inventor operator, one of the two. But it's that combination that makes you unique, and that means when you invent your next machine, you'll stun the world again.
Oh, well, the next one, we'll see what happens the next one. The 25 tonners, I'm quite proud of them because we're the 25 tonners we're building is they're built them with everything I've really wanted my whole life. They've got two engines on them, so I built them with two engines instead of one engine because I didn't want the fact that the recovered engine's back there. So if the doomsday happens that one engine goes down, just turn that engine off and that one, and they can still work with one engine. But I think in Williams' generation, the law becomes like a hybrid, so there'll be one engine and a battery pack. So that we'll go into tunnels working with fully battery, and when the batteries need charged, the engine will kick in and charge the batteries. And that's where the way it's all going to go. But I see that the technology is there, we just need to work with it. That's really, because as I still maintain, the UK is probably it's no probably, it is the best rail system in the world. We're fortunate to work here at the UK. And I know you know a lot of folk say that, but we've been around the world. I've been around the world many times in Philly's fog, and I can tell you it's the best ever.
Nobody's disagreeing with you in here, but
Honestly, I've been made that way 3 times and that way twice.
Or fucking both over it.
I have done isolation. I've done isolation in the New Zealand to get into the country because of COVID. I've done isolation to get into America. I've done everything. Doesn't matter. We have got the best system in the world, and that's a fact. I like.
we invented it, didn't we?
That's what I'm saying. If you couldn't,
Yes.
No, we're very fortunate. This is our home market that we can test and we can work, and yeah, we're very lucky.
at Ballantrae, in a secret location in Ballantrae, or no place where it is, we have an 800.
Fuck about Trey.
It's not so but an 800. I've got an 800 double track system that I have there, and I can strip it to pieces. We brought the Malaysians across. The man touched my shoulder. And there he says, "Can I film you?" And I went, "Why do I touch my shoulder?" He says, "So we know it's real time because the trees are all gone last." I said, "No." And they bought the machines like that because we lifted that panel, set it there, and it went from Malaysia to Kuala Lumpur. And it was something like 15 years, I think it was.
And they were cutting it from 7 to 4, but
Aye.
we were home to get it down.
Down again, and I was saying, and that's the difference. Having the tools that Network Rail gifted us, all that stuff that still belongs to Network Rail, and we have that at my disposal all the time if I want to.
And again, but yeah, Network Rail, they gave us that railway track so we can build that test facility. So again, yeah, absolutely. We're getting that help.
There's no doubt about it. We have some really good people in Network Rail, and it's no because it's like this job we're going in Florida, 260 meters, 260 feet panel, right? So we'll just build that new yard, and we'll bring the operators, wherever they come from, it could be England or Scotland. We'll let them play with it for a while. So when we hit that gun in the States, they'll do it. I don't ever want to turn up at a job in the back foot. That's never going to be me. I'm never going to. I'll take that day off.
This is building your Formula One team.
That's it.
If you're going to go out midweek nights,
That's what we need to do.
that's what you
Every person needs to know what they're doing on that day.
Yes, and they don't need to be told. They need to walk on there and do what they're expected to do. Yeah, absolutely.
Absolutely.
That's where we need to get to 100 to 200 meters midweek, 4 nights a week. I'll give us a mile. That's half a mile, just over half a mile midweek. 2 weeks is a mile of renewals in 2 weeks.
Yeah.
That's what we'll do.
We've had some comments online. So Angus said thank you to you both. Your enthusiasm is refreshing to hear. Real solutions to railway challenges. And then Peter Hemingway said, have to dial off, but thanks very much. Great job on Metrolink over the summer.
There's Canada in Toronto.
Oh, we do a lot of Canada.
No, thank you very much. We really enjoyed it. Hopefully the last minute substitution was okay.
Usually that's probably always. Usually that's probably always a part where I always apologise for the language barrier. Well, we say, "Oh, sorry the language," but I want Stevie can speak. We speak Scottish, obviously, but Stevie can speak and you can show what you're actually trying to achieve, and probably the enthusiasm is usually what comes out. And it doesn't matter what language it is. I've listened to music for God knows to what. I don't even know what they're speaking. I don't find I can enjoy it. And that's the difference to be a railway guy. I can sit and watch a presentation with somebody speaking and how to work out and how to do it. and I can work it right very quickly. I'll go, if that guy's telling me that I want to know, or I'll go back at the school and look at the window. So it's right. What was the question earlier that I asked you today? What was how would you gain that man time? Probably do with time, innit? Time is the right one.
It's the principles of work study. If you wanted to know
Times
how to do work study properly, you ask the laziest man in the squad, how should we do this? And the laziest man in the squad will tell you.
So I was in Brazil last week, right? So that job I was telling you earlier, right? So they were intrigued by the fact that this was because iron ore trains are between £1 million to £2 million a pop, right? Which is in your language, that's a lot of money, right? In anybody's language, probably. So we goes onto the job and that palaver, so there's watching it, and the guy says, "Oh, we need X, Y, and Z." I went, "Right, that's fair enough." So I worked out very quickly that when in the back, and I thought, if I can split this job into two, I've cracked it. So these machines at the panel lifters could travel this way 24 seconds per 60 foot, but the job is 700 meters long. So that gives me 24 panels, 24 meter panels. I'm giving me 30 runs. That was easy. So what they all did, what I think they all failed was, this was the point of access. Everyone's the mafia. That was it. That was where I thought, in my tiny mind, was they made their mistake. Because I had to wait in every panel coming off before I could start redoing it, because it's a single line viaduct. So I'm sitting going, right, how do I convince these folk that if we can do something else, would they trust me? I thought, right, so the strings are 120 meters, and I thought if I could do 240 meters, I'll get this job. So I'm sitting there, all these people like yourselves, Portuguese. I'm sitting there going, how does a Scots guy talk Portuguese here? So that against this, there's a whiteboard out there, that's a television. But so I just draws a curve. That's right. So and this, that was it. 240, 240, 240. That's it. What happened next? The penny just absolutely fell down. I tamed enough sleepers for this year with 8 trolleys, and I parked it there. That was it. Taking the Unimog back for there. So that was me. When I lifted the panels out with that panel machine, I could step with them with these sleepers. That was me, had 1/3 of that job done in that time. So that means I'd only 2/3 of the job today coming to this. And that was, they were starting to do what they were more important was, how did they get their last 2 wells done? They were doing the last 2 wells first. And that you can hear the pin drop.
But see that ability, you're identifying straight away the bottleneck. And then you're thinking, applying all your brain power and overcoming that bottleneck. You're thinking, how can I do this? There must be a way of doing this better, cheaper, faster, smarter. And then you get your wee light bulb moment, and then all you've got to do is get in your Portuguese thinking, and on your whiteboard, show them how it can be done. That's what people don't have. That ability to do, that's called first principles of engineering. You are identifying where the impediments are to work and where the shortcuts can be taken safely to produce a better, safer, more sustainable product than the day you're building more for less money, safer. Because you're not taking one item from one end of the world to the other. You are thinking, we can do it better. And I was thinking, you were dropping them over the side of the viaduct. Right? But obviously I'm a bit further in my advanced thinking than you are, Billy, but I was trying to think, how do I get them back once I've dropped them off, dangle them over them. But these kind of things happen. You know, you're stuck there. I remember being stuck with a dead class 37 and 22 turbits of stone at Lockerbie. How did I get them off the track? And I did. All I had was a JCB 4x4. And all I did was push the last wagon, push the second last, which eventually pushed the loco, keep it going. And all of a sudden he's in the loop at Lockerbie. Job done. Let's go home to our loved ones. Monday morning prayers meeting after that. How the hell did you manage to think that? If people are in the meeting, I had a problem. I had this, I had that up there. I had to join the dots. People that think that way, the railwaymen in the world, in the team, in here tonight and online. These are people who are on site, who can see a different way of doing things quite often. And the thing that beats most people these days is getting it vocalised and out. We used to have a thing in the railway called Win a Suggestion Prize. I think it was £25, could be 50 for the successful suggestions. I was a regular contributor. Unfortunately, sorry if you're listening, Eric. Eric would sometimes beat me down, Mr. Ryder. Right, so when I had my brainwaves out on site on a Saturday night, driving home on the Saturday night, you know you're doing the job again. How would I do it better? You're thinking all the time, how could this be done better? You come up with the brainwave Monday morning, straight in. Boss, win a suggestion prize, £50 coming my way. Put the suggestion in. Somebody says, no, we can't do it. That doesn't beat you. You just think, okay, not on this occasion. I'll come up with another one. I'll get one in. And you just keep plugging away at it. And I'm still doing it yet. I don't have many successes. And you, Billy, are fortunate to have lots of successes. You can look back in your career and go, I did that. I invented that. Look at this thing over here. That's mine as well.
So I've done see it. So we're involved in a job in Mexico, right? So a couple of jobs in Mexico to Trademark.
Trademark, yeah.
Right? I'm not showing their stuff. I'll just show them this stuff. Right?
Still, it's an easy,
That's
it. Yeah.
That's
oh,
They gave. So what happened? That's so. So I'll show you this one first, right? So this is what happens in New Zealand, right? And it's we're the same people as I said. So this is. Oh, sorry.
No,
This-
Robert,
right, yes. So this is the job in New Zealand, right? So this is where we. So what happens here, right? So this is.
you talk, I'll hold.
Right there. This is the job there, right? So what happens here? This was the top. So the top job was there, right? So you had to build a haul road. The whole point is you've got to build a haul road to take the panels in to their job. So that was 200. That whole road there was 250,000, right? So I'm sitting there going to myself, no, we're not doing that. So this area here was all cleared. The generation game.
This is a real slideshow.
So that was this area because I was out there with two Maoris, Mike and Steve, and they call them the fast food near shooters are still new bigger than they're humongous guys, right? So the boat, the steel comes in from China, steamers come in from somewhere else, they're all lining it to Auckland Yard. So we're driving up to Auckland Yard, up to Vangaree and Palaver. So see at the more dotted about that, us Palaver. So the next time we're going to clearly every site's 250,000. They've got a goat track down there to get in there. So I'm sitting there going, right, we're doing this one here, we're doing this one, we're doing this one. And I went, well, what happens if we do the last one first? And they're sitting looking going, why would you do the last one first? That's because we should always use what we have, right? My theory is, see it, use it. So what happened next was, I said, well, this is a big fella says to me, says, the rails are doing in Auckland, you need to come up to Vangaree, we couldn't drag them up one at a time. So I said, why don't we just put them into your trolleys? That was the first, put them on the rail. So if you take them up on the rail, right, that means lift the rails off, get the sleepers up there, build the panels on the top of the existing rail that you've took out, because that's the tunnel they're boring. If you lay 12 panels here, build them there, you don't need all this ground. So every job, there's 250,000 was saved on the jobs. So what happened was, so I don't know who actually got the job here, right?
Dollars.
Australian. So that's the rail line there in Mexico. So Mexico's the same, right?
Meanwhile, on the other side of the world.
So that's Mexico. That's one. So that's there, right? That's it there, and that's another one with a bridge. If you see the bridge, this is the bridge. Isn't that beautiful, right? That job was stopped because of environmental people. Right? So environmental people went, so they're going to cut the railway line, we're going to use a haul road, and then we're going to have a service road. I went, no, we're not doing this. We're not ever doing this stuff. I said, we'll use what we have. I said, so we'll got the rail in, X, Y, Z, and we'll take the sleepers, we'll Unimog, and do this. That meant you have one base, you can travel 50 miles, take them off with the panel machine, build that bit of rail, take that back, and advance the way. If the Romans ever built railway, that's the way they did it. That's 3 days. So all the trees in the Hall Road, all the trees in the Service Road are still alive today.
Excellent, sustainable.
That was
green.
why they wanted to stop it, of course.
Huh?
That was why they wanted to stop it.
Aye, they stopped the environmental people stopped it. Because they're cutting far too many. They were taking swathes of the forest. So face, you don't need it because you actually got a service road, sorry, a Hall Road, you need a service road to feed that beast. But if you've got the railway line and you can travel at 20 mile an hour, if we say that's 40 mile an hour, it doesn't matter. We can make that system. But that's a 355 system. If it was a 709, we need 4 runs a day to do half a mile of track. And that's where the savings was. And the trees are still alive.
I think, see if there's no more questions online. I might do the vote of thanks, let people online go, and then you can ask any more questions in the room. That sounds all right to people. So last shout, if there's anyone online, get any last questions before we close out? Okay, I'm just going to give a quick vote of thanks then. I'll go through my notes I've got here, much of the same points Tom picked up on, but worth repeating. Firstly, thanks for a great presentation, guys. Absolutely amazing to hear how McCulloch's group started and was growing significantly into an international company. I certainly remember being out in tree cutting shifts with you in the early 90s, so it's changed quite a bit since then. I was blown away by the vast array of machines and how unique they are. As Tom said, they're not just versions of existing machines, they actually solve problems. The beauty of the machines being the ability to work under live OLE. And great to hear how that was so significant and much of a benefit when working for Amtrak and Effectively, I think it was, with the industrial action prevented permits being issued. So apart from the production and efficiency benefits, many of the machines bring safety benefits in terms of being able to work in adjacent line open conditions. The MMPV having the cutout facility as well, you mentioned. Control facility of the TRT allowing operators to work the machine but remain in a position of safety, and for exclusion zones to be set up as well. So simplicity as well I've got, as well as all the parts of the machines being easily replaceable, which is a massive benefit. And it seems that everything's been thought of in terms of, like the panel lifter being able to fold up and delivered on one lorry, sustainability benefits from that as well. And the TRTE, which is the zero emissions as well. So amazing. Other things I picked up, the TCT being able to replace, the work of 25 people, 5.5 kilometers in one night, removing the amount of joints. MMPV machine looks like a dream machine. So great to see the TRTE with the zero emissions and the decent charge time as well. Not only just environmentally friendly, but if it ran out in 2 hours, it's not that much of a benefit. But I think it's at 8 hours, something like that for that one. So amazing stuff. So you're definitely set for world domination. I'm sure you'll break through into Europe and add that to your list of areas around the world you're already established in. So I'll just finish up and ask everyone to join with me. Thank you, and a vote thanks.
No, thank you very much for having us.
Thank you very much. And my theory is, at 3 in the morning, you can't phone Ghostbusters to fix the machines, fix it yourself.
Yep.
Too technical, some machines.
It's kind of taken forward a principle that I think we're just kind of bubbling away in the end of PR days, when they decided it wouldn't just be camper operators, it would be operator fitters. I don't think it ever came to anything, but you're taking to something.
Honestly, we go from one track for the Val block to the faraway track, and I'll say it's all money, it's 10-foot hose, and that hose is the only hose I'll give you, and it fixes that machine. And it comes with 2 19-mil spanners, and that can go to any truck. It's not the prettiest thing in the world, the instant gets the job, but it goes for there, tubular hose, it goes to any of the motors in one truck.
Right. So every hose fitting is standard there.
Yeah.
Can't go wrong, can
No,
it?
no.
Just means you need one spanner.
Ah.
You don't have to have an array of spanners, so you don't have to have a full kit with you.
I'm not having that. I just, because, where's that bit? Oh, it's in the van. Where's the van? Oh, we didn't bring that one tonight. Oh, wait the new gear. See, both actually, I think that's the luxury we have, and as a fantastic luxury we have, the fact that we can actually play in a live railway in this country to actually see if it works. And see if it didn't work for us, we wouldn't sell it. And that's a fact of life. I couldn't, it would never be us. I enjoy the fact that I love the fact that somebody said, it's always when I went to England to start working, I went to someone, it's all right, son, I'll no work here. They don't cost so much sun anymore, but it doesn't matter. But it's always the same principle. I said, it can't be because it's the same rule as Scotland as all the way in the world.
Yeah.
If you're showing that, it doesn't, it's a myth. It's no different.
And in so many ways the same. The minute you walk into New South Wales and you think, oh, I heard about broad gauge and narrow gauge. I haven't heard standard gauge, this is a doddle. And then you walk into Melbourne and think, oh, sorry, you're broad gauge. In fact, dual gauge here,
Yeah.
you in freight, you're in standard gauge, you're in your passengers, well, you're in broad gauge. And the dual gauge turnout, your type 39 or whatever they want to call it, well, it's got more rails than tongue can tell. All moving about. And that's the thing, that's somewhere where, you know, they've got that, you know, the polyvalent sleepers, they've got the turnouts figured out with their dual gauge, what's going where. So when you got a dual gauge turnout with everything able to go on the diverging route, you've got rails that are joined up that you wouldn't think would actually work when you look at something. I mean, it doesn't actually work. You've got to follow the running edge all the way through. Tricky. And being able to work in all parts of the world just brings me back to the fundamental thing. The railway's the same the world over. It's a
Absolutely.
guided transport system.
That's Malaysia, Banda Panel. I stopped counting at 60 men.
Oh, right.
I mean,
It's made of age as well, of course. Paul.
Eh?
It's made of
yeah.
age as well.
That is.
there was a picture in Jim's place at Bowness in the museum. It's a picture of the big squad at Carstairs, right? So a picture of Carstairs at the station junction where the track was at
Used to be
negative 80 can, 5 mile an hour to Edinburgh, all that good stuff. And it's taken, I guess, in the mid-60s. It's kind of that vintage of the big squad at Carstairs. And when you get past looking at I looked at the photograph and looked for people I know. Fathers of people I know, that kind of thing. But when you look behind that and look at the track quality, you think they didn't have a single tamper anywhere near it.
Nope.
They were done by hand, and there's not a single ballast stone out of place. And it's like unbelievable how you can look at that picture and you think that's got to be staged. It's got to be, no, it's not photoshopped. It is what it was.
What it was.
It's just a picture that somebody took one day of the big squad at Carstairs Station Junction with the sheds behind them. And it's that kind of thing where we've got masses of manpower that we used to have in the railway, we don't have anymore. Maintainers not maintained to do much other than inspect and kind of little bits of fixes, respond to emergencies maybe. But after that, it's renewal. And quite often I think we shout renewal far too quickly. But it's good to see that when we do shout renewal, there are people like you that say, do you know what? We can do it in far quicker time. I'll do it midweek.
Go to do it, Maggie. We'll go to get
Because we get away from the weekend. Somebody said Sunday, Monday is going to be the new weekend. Nobody wants to go to work on a Monday. Very few people traveling trains on Sunday, allegedly, but I think it's getting busy. Whereas Saturday now is busy for trains.
Yeah,
But
I think you could say, well, what we do have to realise is the railway is changing. And it's changing because society has changed, because of COVID, because of other things. It's weekend is going to be the popular time.
But the
And not
expectation,
just the popular time for passengers. It's freight. We're running freights in we never used to see freights in Scotland after lunchtime on a Saturday. Well, we do now. And that's going to be more prevalent. So we've got to look at midweek opportunities.
if we could integrate freights in amongst passenger trains seamlessly, without need to loop them, stick them into the summit loop while something goes whizzing past. If we could do that, our railway would be much more monochrome and friendly. But we don't. We say rates are limited to. Why? No, it's not passenger comfort. Is it tractive effort? Is it pull and pull? You look at what they do in Australia. They get Melbourne, 3.5 kilometre long freight train. You said to me, we've got a 3.5. We want to get it off the main line in an inland port, and we want to do it a high speed turnout, 40 kilometres an hour. 40 kilometres an hour is not a high speed turn now. I was falling off my seat at this.
We were
thought.
lucky, as us, as well, you know, we were lucky if we touched pastures probably 20% of your life. It's off rate. All every we touch is free, even like a CSX off rate, benefit
Americans.
off rate. That's where the money, big money
They're
is.
starting to invest
They're
those.
starting to invest
The
because
next sort of 10 years in America, a lot will go high speed. There's a lot, they've done it in Florida, they're looking at it in Texas, they're looking at it in California at the moment.
Wouldn't they have to
A lot of
have
high speed
it
railway.
because of what's hauled by roads in America?
we went
Got to get
to,
away from that.
we went to, there's a Pittsburgh or something, I reckon.
Pittsburgh, yeah.
We went to, the guy says, the railway guy says, to me, what speed does your trains go in the UK? I said, well, probably about 125 an hour. I wouldn't have put my family on that.
Yeah, you put it on an air eye, right?
I think there's, is that a 300 or 420 bridges into Pittsburgh, right? So you come out of Pittsburgh to do a job, right? And it's 3 hours, you sit there in traffic to get into Pittsburgh 3 hours, and with this big cup with a coat, that's it there, and they sit there quite happily for 3 hours. Get back home, same 3 hours. And I said, he's never had a parking right. Ken, we've got that many bridges, there's some, I think there's over 400.
Yeah.
It's absolutely phenomenal how many bridges they've got, and yet they seem to love this car. But I would take an advert on the TV to go, right, I'll tell you what, this guy's sitting in this train for 20 minutes, working, bang, get to the office, get back in. This guy's sitting in this car for 6 years, his life, but no his working day.
Just to get to his work.
And to get to his work,
Is
that's a
it-
bit, you know, he always doesn't like his home life, that's why.
Maybe that was a problem. Him and the missus didn't go.
No, but you don't, it's far too much, you know, I just think that, and we are very fortunate, I'll be honest with you, when I left the school with just my hands and probably no education or whatever.
Thanks for this presentation, guys.
Thank you.
The education life that I life, and I'm very fortunate to have that, but and I think
Okay.
being Scottish is a plus for everyone because you seem to, you navigate different ways in Scottish, being having who you are and what you can do. You can improvise a lot better than I think anybody as far as I'm aware. And that to come to this country and back home to work in the railways, to develop stuff and to market it globally is, you know, I think it's brilliant. There's no
It's a good, what you're exposing here is the ability of the Scottish engineers, particularly, to be able to problem solve. They do a lot of problem solving in Australia. Right?
a huge amount everywhere.
Who will fix things, and the first time I saw a temporary crossover in Melbourne for the tram system, I went, this was before it was invented here. Was it? Well, you just nail it to the floor.
Did
Oh,
I?
aye, it works. You know, and you think, do you know what? Why don't we do more of that?
I couldn't work it. I knew the guy. In fact, he must be the tire. He was out with Celtic Park. Out there,
Woden Street,
was it what do you call it?
Woden Street,
What was his name?
Henry Maxwell.
Is that-
amongst other- Well, he was one of them.
Some shits.
REA, yes.
Because he was the retire. He was going to sell it,
I think he sold it.
right?
Because what's his name, Ranges now, got his finger in the pie there.
But that's the thing. But I couldn't. So I think he offered me, but I couldn't remember if he did it. He did, but I couldn't remember which one it was. And then I googled it. Didn't Google it. We're in Melbourne, and I seen this thing. I'm going, and this guy said they had a patent on it, but yet Melbourne tram has got the crossover. And I'm thinking, how did you get a patent?
Yeah.
They've got it. They said it's just nailed it to the gun.
I've seen
couldn't
this
believe what they
a YouTube video somewhere in continental Europe. Again, it's the same thing. It's nailed
And
down
so,
on the street.
now that I think he was
Up
looking for
over,
£1 million.
down.
I think I've got fun of me. He's looking for £1 million for the
For
sale.
Lex, right,
But-
okay.
That guy's just nailed it to the gun, so he's not got £1 million.
But the beauty of that is, if you think of Edinburgh Tram. Edinburgh Tram is built on being able to sustain a 1 metre wide void below the track, like water main, washout. The track had to be big enough to handle that. If you've got something that can do it effectively, a single lane closure, it's a lot crossover left, crossover right, but you've effectively got a wee bit of single lane working you can put in at the drop of a hat to allow the utilities company to fix the water main at their leisure, adjacent line open, of course, and they're but rather than build the entire track form to be able to sustain something that generally or 99.9% of it will not need to happen.
Yeah.
So you save money in your track form design by building a lighter, not say very lightweight track form, but something like that. Because you've actually invented a system that can do a very short waves. The utility diversion thing, the same way as people put up traffic lights, you sit there going, this is the second time this week, this was been short. But at least everybody could move around the house. And that's the thing, that invention.
It's a brilliant invention, absolutely brilliant. I love it.
It's like, okay, so somebody just thought, well, what I want to do is I want to be able to take that tram for there, put it on that line and bring it back again. So no, we would. I was in Melbourne, I used to work there. So when I was in Melbourne doing the main interchange, the big interchange from outside into the CBD, we had to shut the main interchange. So they said, well, all the trams at CBD, we'll just turn them back. You know, you've got nothing. And I would just put a crossover in. And it was just a single crossover. Trains come in, a little pocket track, right to crossover, and back down again. Same again, push through. It's simple.
Actually, they used to.
It's simple.
For pennies, and that. That's so simple. You could do that at Croy. If you had to, right? Just to get an idea.
I couldn't work out why that guy was. I remember being to Real Live, and that was introduced, and they derailed the train at Real Live, and it was only because it was warm and it didn't take tails, and the thing came off, and I thought I felt for him, I really did.
I remember that.
And I thought, oh no, that's a shame, because I kind of have to do him a wee bit, and I thought, oh, it's that. So if we ever go to Real Live, we would never do a demonstration.
It wouldn't happen to you, Billy, because do you know what? You would have had a driver in all weathers before you even expose yourself to public scrutiny.
We at 7 in the morning, make sure it was done.
I was speaking to that very person the day and he mentioned that.
Did he? Oh, I feel, it's a good job as a main scuff crane sitting there to lift that back on. But I was sitting there going,
He said it was the front of the grandstand.
oh, it was.
Front of
It was a right shoe.
That's the high pressure situation, and you can't always control everything. That's
No.
It was all men. Yes, what you say. It was all men. We did this.
We're just showing you.
Quickly, we could
Get it
rewrite
back
it.
on.
Wouldn't me. I love going these things shows and that, but it's we didn't win last maybe when did we talk to Tuxworth?
it was last July.
Last July, we decided Real Live became an absolute fortune, right? And I just don't like it because it was costing us like for a 30-foot panel, it was like
120 people still.
to get in that panel.
They'll cut it up for YouTube.
You can hang it up.
You could do, yeah.
I'll choke that bit off after you give this. Sorry, Terry, you can jump up again.
7.
No, that, 10 has happened.
We stop hearing this.